Good morning, friends. This is Somnath Chattopadhyay from the Department of Mechanical Engineering, Indian Institute of Technology, Indian School of Mines, Dhanbad, Jharkhand, India. Today we are going to discuss about the topic of welding processes and its principal introductory part. And from the title topic we can see this arc welding is taking place, and with this droplet deposition the material is or metal is deposited, and according to that the welding or coalescence or joining is taking place. Our objectives is principles of different welding techniques: gas welding, manual metal arc welding, metal inert gas welding, that is MIG and TIG welding process. This will be very rudimentary way. We will cover only the introductory part of these processes. We can see the gas welding oxyacetylene, that is gas welding with oxyacetylene. We will study these things and we will discuss, and that is a very important method. The beauty is that it is independent of the electrical technology. We in remote areas, inaccessible areas also, we can take those cylinders and along with this attachment and we can start welding. That is the beauty of it. And it with this oxyacetylene flame will generate the appropriate amount of heat where the parent material will melt in the surface area where the joining has to be or coalescence has to be carried out, and according to that it will be there. And there are some pressure control valves are there, pressure gauges through which the flow of all those gases will be there, and there are the cylinders along with the cables. One can easily find it out that one is the red, one is the acetylene hose, red, and acetylene cylinders also is in the red color, so that people don't make mistake out of it. So red is the color, representative color of these acetylene C2H2, and black is the color of these blue or black is the color of these oxygen cylinder, along with these hoses also. Hoses are also the similar color, so that people don't confuse with oxygen and acetylene flow, and that is important. And the valve closing also, one is clockwise and another one is anti-clockwise, in order to ensure that which kind of cylinders it is. And in the remote inaccessible areas there is always a chance that the color or the paints of those cylinders are eroded, so that color will not be visible. Even in terms of the locking arrangement of those valves, and those things can be easily pointed out that it is a case of oxygen cylinder or it is a case of the acetylene cylinder. And this is knowledge is crucial, and this is put into these nozzle and they are mixing, and on the basis of that it is delivering with those needle valves and oxygen and hoses, and they are responsible for putting there itself, and with those gauges we can control those delivery, and they are ignited, and on the basis of that the heat will be generated. Heat is responsible for localized melting of those surfaces needed for coalescence, and maybe some cases the filler material is added. If it is thick, higher deposition is needed, and whenever it is not, it will be just autogeneous welding type of process. So one can see this torch. The torch tip is delivering this mix oxyacetylene as the name suggests, and all those things are mixed in the torch handle, and this torch handle is constituted of the barrels, and there are two valves are there also, so that one can control. One is oxygen valve, another one is acetylene valve, and the filler ware is there as a filler material if at all it is needed whenever the flame is ignited, and there that will be also concurrently melted as the support of all those material provision for better deposition rate. And the places where the actual coalescence has to be taken, there people utilize that. So this is a typical diagram through which depicting through which depicting about these the constituent of those oxyacetylene torch. So some bigger details. So one can see those different colors also. Here oxygen is represented by green, as it is related to life, and acetylene is red, and this torch and all those representation and how it is implemented as a bigger view, where it is actually implemented there itself, and this bead geometry is finding it out, and the welding is taking place. It is a very crude and blunt welding process, but it is very handy, because in those places where infrastructure already not built and remote places where the fabrication other things has to be carried out, the electrical substations and other things are not installed. This is the only way left out where people can do these kind of welding process. And one can see the different types of flames. The neutral flame, three types of flames are there: neutral flame, carburizing flame or reducing flame, and oxidizing flame. Neutral flame where oxygen and acetylene is similar proportion, so it is neutral. Carburizing flame where acetylene is more, so it can do, apart from heating, it will carburized. And the third one is the oxidizing flame where oxygen is more and acetylene is less. So as more of oxidation, oxygen, so it will deal with oxidation of all those things, and on the basis of that oxidizing will be there, so the flame is named. But here the constituents of all those flames, one can easily find it out. Some actual flame, that carburizing flame have the different kind of construction of the feather inside. Neutral flame has a different one. Carburizing flame has these two stages of those feathers, and in case of oxidizing flame, the different kind of feather, and their character is also different. From this feather itself, one can easily find it out that what character of the flame is that, whether it is a neutralizing flame or is a carburizing flame or a reducing flame or a oxidizing flame. And there itself, without knowing testing of the gases, people can find it out, and they have their own application. Carburizing, so it will do some carburization, so some hardness will increase. Some cases we require oxidizing, and most of the cases neutral flame will do the job of welding. And this is also a puck cutting machine. Why puck cutting machine? The advantage is that it is semi-automatic. It is mounted on some channels or rails, and on the bottom rotated, and so it will traverse. It will traverse with those pipes. So advantage is that, so one does not require an operator after it is just initiated starting of those machine or the system. So thick plates can be cut, linear cut, depending on the rails, maybe a long length, few meters after meters it can do, as long as the length of those hoses permit of those travel. Its beauty is that no human intervention while cutting is required. Initiation, yes, it is required, but if it is not, then definitely it can be done without human intervention, and it is a very productive process. Even very, very thick plates can be cut, and it is done in a mass fabrication unit of all those things people are using. Without this machine, these kind of productive cutting cannot be ensured, because it will require less amount of labor. It's a very handy rudimentary machine of cutting all those thick plates, but definitely it will ensure as a linear cut. This is known as puck cutting machine. One can see this. The next one is manual metal arc welding machine. So here these electrodes, flux coated electrodes are there. Flux coated electrodes, these flux will melt away and produce the slag, and it will emit some appropriate gases to drive out those oxygen, atmospheric oxygen, keep a gas jackets outside the flame, so that the elevated temperature of the molten metal pool and these heated material, parent material, are not getting oxidized. They don't come in the touch of all those contamination of this atmospheric oxygen. The advantage is that oxides will not be formed, then the weld's homogeneity, quality and strength will be great, and that was a terrific discovery. After this discovery of all those things, oxidization prevention strategy, welding becomes successful. And so successful, the beauty of all those arc welding is that if it is done properly, then the strength of the weld is more than that of the molten metal, this parent metal, and that is terrific in terms of the joining one. If we have done it appropriately and put it into a tensile testing machine, then the joint will not break, the parent material will break, and that is the unique selling point of these welding process, metal arc welding process. But one part is that the top part is the naked one, which is grabbed, because in order to complete the circuitry, if it is coated by all those different kind of oxides, the problem is that they are the insulated material. So the tip has to be kept naked without the coating in order to ensure the circuits, completion of the circuits, and that way it is implemented in coating activity of all those electrodes, and that way the coating is, it is one of the most primitive arc welding process. So this method is one of the most widely used also, arc welding process widely used, because other arc welding process like MIG, it required the big coils, bigger machine, and not that handy. TIG also, it required a non-consumable electrode, but manual metal arc welding process is very handy and less costly, with a very small setup, with low cost setup, low initial cost or first cost. The welding and other things can be carried out. So that is why extensively popular, worldwide popular, in order to do these kind of welding process. It requires considerable skill, but the problem is that yes, to produce good quality welds. So for mission critical applications, we need certified welder, and this certification of the welders are also depends on the different position, 1G, 2G, 3G, 4G, and all sorts of positions are there, where the horizontal part of it is easy, but the sealing overhead part of it, the welding is difficult. So a lot of skills are required, and definitely depend on the different stages of the skills because of their applications. The electrode consists of a steel core wire and a covering flux. The core is the electrode, and it is a sacrificial electrode. Electrode is sacrificed by melting, and it is acting as a filler material. So electrode as well as a filler material. So consists of a steel core wire and a covering flux containing alloying elements like say manganese or silicon, so that it has some properties. That is the flux related properties, so that it can cover those jackets while melting down, form a very good a slag which is can be easily chipped out, and that way they will pull and other things. The quality is ensured, their homogeneity is ensured, the strength is ensured, and maybe a little bit of gas coming out of it, and this gas is acting as a very good gas jackets, preventing the atmospheric oxygen to come in contact with those molten metal pool and these parent material at elevated temperature. So oxide formation possibility is minimum. The arc melts the parent material and the electrode in the vicinity of the places where the coalescence has to be ensured. So as metal is transferred from the end of the core wire to the weld pool. Weld pool is a common weld pool. Solidification, after that it will be shared by those parent material, and it will be the place of the joint. And the welder moves the electrode to keep the arc length constant. It is important, because bigger if it is, arc length will be extinguished. If it is smaller, it will be burned through. So keeping that length appropriately, so that the arc welding is in appropriate shape and delivering the goods, is the skill of an operator. So operator in all said and done situations has to maintain this gap, and that is why it requires a lot of skill. And this is essential, as the width of the weld run is largely governed by the arc length. Arc length has a role to play in terms of the width of the weld. So different bit geometries features are there, that is, one is the bead width, one is the bead penetration and bead reinforcement, and all those things are important bit geometries and these are all yield parameters. After the sectional cutting, people know these kind of bit parameters, and these parameters have very important relationship with all those process control parameters of the welding process: voltage, current, and travel speed. And the flux melts with the core wear and flows over the surface full to form a slag, and this slag is chipped out, removed after solidification, and slag formation is such that it can be easily detached from the weld pool, and it is removed by chipping. So the functions of the slag produced, the advantages of using it: it minimizes the impurities in the weld. With oil, with this flotation process, it will take away all those floating impurities in the weld. It will form a perfect jacket which protects the weld from oxidation, and that is crucial because oxidation will jeopardize the strength of the weld, and that is not known before World War I, and that is why welding application was very limited and it was only for the academics. But when people know that it can be prevented, or if oxidation is prevented, then high quality weld will be there, then definitely welding is becoming the process of joining, and tremendous application in the post World War II, during World War II and post World War II period. It ensures a slow cooling rate for the weld, and that is why the strength of those old bead is stronger, and it prevents cracking and brittleness. So weld is very strong, but little problem of but if it is protected well, hydrogen embrittlement is there in the peripheral level, but mostly because of the hydroids production. But here itself, if the proper jacketing is there, the cracking and brittleness is less. The reason is that it is cooled very slowly. So the manual metal arc welding, the circuitry is like this: the power supply unit, and it is feeding, and the other, it can be AC, alternate current or direct current, the welding return, the circuit is completed, electrode holder is there, flux cover, the stick electrode is there, and the arc formation with the appropriate gap with the weld, it is maintained. So the electrode is fluxed covered steel wire, and it is near about say 450 millimeter long diameter to match the current level. So different kind of welding currents are associated with different kind of the diameters of the weld. And this control is current, voltage, electrode feed, and the travel speed. These are all four major process control parameters of the weld, and the yield parameters are the destructive parameters are that is the tensile strength. That is the most important parameter of the welding, how strength of those weld. And the next is bead geometries, bead penetration, bead height, and bead reinforcement. So the transformer circuit is basically a step down transformer, because the voltage is reduced from 220 voltage to 100 voltage. Why voltage is reduced? The ampere is increased. And why? Because H is equal to I square RT. The heat generation is square proportional of all those current, I square. And that is why it is always better to go for higher current. And who will do the higher current? At the compromise of the voltage. So V1 I1 is equal to V2 I2. And in order to reduce this voltage, we have to use step down transformer. That means the voltage will be reduced so that the current will in equal proportion and will be increased. So 220 voltage is coming down to 80 to 100 voltage for welding, and subsequently the current goes up. And this will provide the high current needed for the welding, because higher the current, it is getting more heat and it is responsible for the localized melting. And this type of transformer has more turns on the primary coil than the secondary one, because in order to ensure this is a feature of a step down transformer, and will induce alternating current at a lower voltage. And the rectifier, the role of rectifier is changing alternating current to direct one. That is the role of the rectifier. and it consists of 4 diodes, which allows of the diodes to conduct on each half cycle, half wave rectifier, and the capacitor is employed to provide smooth supply so that the undulations in the power supply is not there. So, it is act as a very good buffer in order to ensure as an the wave and the cyclic thing is less. We can see the circuitry of those transformer. 220 volt is coming and it is stepped down, maybe say 100 to 110 volts, and then they are fed into the rectifiers, and rectifiers will convert it to the DC one. Capacitors will just keep it and make it the smooth flow of the current without any fluctuations, another part of it. Next, so this is the typical gas shielded arc welding process. So 1/3 of the heat and the upper part of it, the lower part of it, the gas iron runs is more amount of the heat, and the filler rod is associated with that, and the inert gases are argon gases. So it is known as gas shielded, not gas welding. It is not gas arc welding, it is gas shielded arc welding. That means arc is there and gas is representative of the jacketing of all those welding process. So this is employed in case of metal inert gas welding and the tungsten inert gas welding. Only difference is that metal inert gas welding, the electrode is consumable, where tungsten it is TIG, it is non-consumable electrode. One can see the typical sketches of the MIG welding process. Gases are supplied, inert gases are supplied, and from the coil the electrodes are supplied. It is coming through, and then in the arc itself it is melted down to form continuously the welding puddle throughout the length, throughout the surfaces where it has to be joined, and those can be studied with greater details, the role of the voltage, current and travel speed on the beat parameters and these deposition rate. Deposition rate will determine the productivity of the weld. That means weld before, weld after, minus weld before. So that is the deposition divided by unit time. So it will depend upon, it is called material deposition rate. So MIG and TIG welding both use an electric arc to create. Only difference is that the MIG is used a sacrificial electrode and TIG is used a non-consumable electrode. So this is the way, and this is the arc is used, and welding feed wear constantly moves through that. Welding, sometimes we can use it as autogeneous welding where there is no requirement of the filler weld, but filler rod, and sometimes it requires. So definitely MIG will go for continuous and high deposition rate in comparison to the TIG, and it uses the long rods to fuse two metals directly together. MIG welding is spool of solid steel wire that is coiled. So it is, there is some kind of arrangement of a decoiler. From the decoiler itself, those MIG wire, the electrode wire is fed through a liner contact tip to the MIG gun, and the contact tip is hot, electrically charged, and it is pulled down and melts, and is a continuous process. That is why the productivity of MIG is great whenever people are going for very extensive fabrications of different non-standardized angles and channels and girders. So this is now TIG. One can see that the TIG GTO welding, that is representative of those things. Gas tungsten arc welding process. So power shielding gases are provided, mainly argon. In some cases CO2 also can act as an inert gases. In non-mission critical applications, these contact tubes are there. The tungsten, non-consumable tungsten have a high melting point, so it can act as a non-consumable electrode. So copper shoes are there, and this electric arc is created, and according to that welding takes place. One can see the tip of these arc of the TIG process. And people are very fond of knowing that what is the difference between TIG and MIG, and there's a very popular questions are asked in various examination, gate examination, Indian Engineering Service examinations and all those things. It's very popular, so we will discuss about that. So, the diversity part of it, a number of reasons, MIG welding the superior choice in case of all those big constructions, the different girders and non-standardized angles and channels, well, is top priority. But while TIG welding can be used for more types of metals, limited its effectivity in thicker jobs. Thicker job, MIG. A finer job, and because the MIG welding machine will give a better surface finish and the bit geometries than in comparison to MIG. So, where precise type of positionings and other things are required, then people are using these MIG, this MIG part associated with it. So, MIG welding can be used on aluminum, stainless steel, and the good variety in terms of the diversity on every thicknesses, from 26 gauge metal sheet to heavy duty structural plates, very thick plates and other things MIG can be done. MIG has a lot of applications in wagon sheet, or in the wagon fabrication, in shipbuilding and other kind of activities also. Wide variety of materials can be treated with MIG. We are discussing about the difference between MIG and TIG, and that differentiation is very important for the exam point of view, understanding point of view, and we have to know that conceptual point of view. MIG welding holds this big advantage because of the TIG, because wire feed acts not only as an electrode but also as a feeler, and it is a continuous process. So, productivity is great, continuously and welder can weld with the MIG because there will be a great supply of all those wire from the coils itself. That is the advantage, no break. So, without any break, people can carry forward because the feeling is done by the electrode, sacrificial electrodes, and continuously coming from the coil. And as a result, thicker pieces can be fused together, because the productivity of welding depends on the material deposition rate. Unit material volume of material can be deposited in unit time, that is called MDR, material deposition rate. That will determine welding process A with B, which is more productive depending on that. So, as a result, thicker pieces can be fused together without having to heat them all the way through. So, straightway we can do it in MIG continuously, and it uses feeler rather than fusing. Welding can be used to weld two different materials also together, because a lot of feeler materials and other things, without fusing all those coalescent surfaces, we can join the dissimilar materials even with the aid of those good continuous feeding of the filler material. The speed, another reason also MIG versus TIG is the speed. Speed is favorable. MIG gun is designed to run continuously long periods of time. It can, and its feeding is also there from the coiler itself, so it becomes more efficient, more production continuously, so it is more efficient. And for large industrial application like the shipbuilding industries or the wagon building unit or a very big machine structural fabrication unit, MIG is the go-to choice immediately. It also lends itself well to automation. So, MIG welding torch also can be put into the robotic manipulator, and on the basis of that continuously automated welding process is possible. Oppositely, TIG welding is much slower process, and that feeding another part of it sometimes a challenging issue in comparison to the MIG. So, that kind of massive applications of the TIG is limited. And the quality MIG welding is known for quantity, but TIG is known for quality. TIG welding, bit geometries and other things are much precise, but MIG is lightly blunt. So, speed is more, quality is not that great. For TIG, speed is low, but quality is comparatively better. So, it produces a fine, clean, beautiful crafted weld that is the clear winner when the details are matter when we are using TIG. TIG works, it also works very well variety of thinner gauge and other things. TIG is better, like aluminum and stainless steel, very thin, Maybe sometimes in case of the autogeneous mode, without adding the filler material, TIG can do that. And for fine-tuned smaller projects like gunsmithing, then toolboxes and all those part of it, mission critical precise applications, TIG can be a very good suitable option. And is also growing in popularity across the larger industries that require precision parts. So, but today's even in bigger industry, they are also going for the precise products and component like transportation, aerospace. They are also thinking of the use of TIG. That is because better quality is coming out of it. Precision TIG welding can be achieved this level of precision, better precise results. We can find it out from TIG in comparison to MIG. And MIG welding, unlike the MIG gun, contains both electron filler material in only one system. TIG uses, as one know very well, that non-consumable tungsten electrode to form the arc. The filler material must be added separately in the TIG. So, TIG can be used as autogeneous welding process, no filler material required, and separately where required filler material, it can be appropriate and operator precisely control the speed and the depth, and it is fed together. Detail also comes from the operator's control over that, because the feeding, how the feeding will be there, what will be the deposition, all depends upon the use of those skill of the operators. And one can imagine this level of precision does not come quickly or easily, because a lot of experiences are there. Good welders are the internationally demanded job all over the world. So, that comes out with a lot of practice, a lot of skill and real time exposure. People can get this domain knowledge of doing those things in a reliable manner. Using two hands and a foot takes more precise training and experience operating a MIG gun. So, MIG gun and other things, one also requires some training. The cleanliness TIG welding is a cleaner production, better surface finish, better geometry and other things, while mill itself manual control. This MIG itself cannot provide that level of these cleanliness. TIG welding is also better for the environment, for its operators, while MIG welding can cause lot of smoke. TIG smokes and other things are less, it is less hazardous for the operators, because less fumes are coming out of it. On the contrary, a lot of fumes are there, and the operator has to be very cautious about not to inhale those dirty smoke, which can have some health hazards in future. The strength TIG welding is used in high-tech, high-impact industry, precise one, automotive, aerospace, because of its ability to produce strong quality welds on the thin material. Thinner MIG is suitable, thinner TIG is suitable, and thinner the TIG is suitable, but thicker the MIG is suitable. And since the operator has manual control over the filler material, the beads can much be smaller and cause less disruption in the surrounding metal. It is not that the flow of continuous metal will be there and there will be deposition. So, the fine precise welding sometimes not possible, because there are always a flow of molten metal right from the fusing of the electrodes. And control over the heat output means that the weld can be strong without burning through the parent metal and repairing work. So, control of all those things has to be required, and which is better in TIG. TIG welding setups to use consumables, and they do need to be clean between jobs. Straightway there are feeding and consumables they require, and also electrodes we are using over and over again, and tungsten because of the high melting point. So, some service is required. But since it does not use a continuously fed wire, TIG welding eliminates the headache that every time one has to change once the filler material is finished. So, these type of sometimes setting and other things is little bit hazardous in order to implement. So, thank you very much for your patient hearing. We have done the detailed analysis and differentiations to understand those processes. Initially, we know that gas welding process, and then manual metal arc welding. Then we have discussed TIG and MIG in details, and we know what are the differences associated with that. and their relevant applications. Thank you.